Please on your camera. Please on your camera. And definitely, we just start chapter 2. After last time, we have looked at the before we go further, please recite Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. إياك نعبد وإياك نستعين المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين. Right. After we look at the how to find the domain of certain function given to Earth. Now, to find the domain of the function, just remember that domain supposed to be number we can substitute into our variables, which make that our function defined. And now we're going to look at the even and odd or neither. Even function or odd functions or neither. So when we talk about one function can be determined. Either that function is even function or that function can be odd function or that function can be neither even nor odd function. So function is an even function if f minus x equal to fx. Which means that when we substitute x with minus x, same. We have the same value. Either we put minus or we put plus, it will be same. And therefore, we can say that the function is an even function. And when we look at the symmetry of that function, it's symmetry about y axis. When we talk about graph of the function and we look at the shape of the graph of the function, it will be symmetry about y axis. So one function, the way we want to determine whether the function is odd function or even function, we can determine what we call algebraically test. This algebraically test, either algebraically, which is we make x, we change to minus x, we look at the value, whether we have the value same or not, or we can test graphically. This is algebraically, this is graphically. Given one function. Normally for algebraically, we test one function not given in form of the graph. And symmetry, and graphically, we test one function given in form of the graph. We look at the shape of the graph. If the shape of the graph is symmetry about y-axis, that's even function. When we talk about function, we will have either even or odd function. even function or odd function. Another one, odd function. Odd function happen when fx equal to f minus x, when we substitute with minus x, is equal to minus of fx. When we substitute x with minus x, it's equal to minus of fx. And its symmetry about the origin. Say, again, same. This is when we test algebraically, and this is when we test graphically. Algebraically and graphically. Right. Either that function, even function, or that function, odd function. Right. The function, we say that neither even nor odd function if, when we substitute x with minus x, we do not have fx, not same as fx. And we do not have minus of fx, also not same as minus of fx. So this we say that neither even nor odd function. Neither even nor odd function. Okay. And when we talk of our graph, the graph that no symmetry, no symmetry. So this is the case of when we test algebraically, and this is the case when we test about graphically. Testing about algebraically test or graphically test. When given one function, we want to know that this function given for us is an even function or is an odd function or is neither even nor odd function. Right. So you know now, by now, that when function is given, we know whether even, whether it is odd, or whether it is neither even nor odd. How do we know? We test. Either algebraically test or graphically test. Right. Let's say one function we need to determine algebraically. the function. The function is even, odd, or neither. Let's say the function is the function of minus 5x squared minus 3. That's the function. The function minus fx squared minus 3. So we not remember that we need to test algebraically. Algebraically test. And the function, what is the function? The function is 5x squared minus 3. So how do we know that? Even or odd or neither? How do we know that? How do we know? When we look at the function, what is this the type of this function? Even function or odd function or neither?
Is it odd function?
I don't know whether odd function or even function we need to test. What is a test? What function? Odd function, what I said before. Odd function. Even function, what I said before. Even function. Odd function, what I said before.
Put the negative
Symmetry
value.
about origin graphically.
Sorry?
Symmetry about origin graphically.
No. Now we talk about algebraically, not about graphically. When we talk about symmetry or what is graphically, now algebraically. What I say about when it's even function, what can we conclude about even function?
The domain is negative.
No, nothing to do with the domain.
The negative value of x.
Uh-huh.
Put the negative value in x. For example, negative 1. So negative 5 in bracket negative 1 square minus 3, and then get the result.
Wait. No. What's the basics? I say that even function. As in this class of the even function. Earlier in this class, basic of the even function.
F negative x equals to fx.
This one, f minus x equal to fx. This is, so we test. We just test. Whether even or odd, we just test. F minus x minus 5 minus x squared minus 3. We just test. Before we go to the symmetry or definitely not domain. I didn't know one of the domain. Nothing to do with the domain. No questions about domain. That's to determine whether the function even or odd or neither. Remember that our topics today is determine whether the function is even or neither. Nothing to do yet about domain. And now we look. Minus 5 minus x squared is, what is minus x squared? What is minus x squared?
X squared.
X squared minus 3. Is that same with this? Is it same?
No.
Not same.
Yeah.
Same.
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 Yeah. Same.
If you say do not same, you have to wear glass, wear specs. Right. Same, I think same. So when same, correct this one. So what is the conclusions? We can say that the functions of fx is even function.
Sir,
Yes.
doesn't that mean we can put any negative value in it? For example, if I put negative 1 and then I get negative 8.
When you put negative 1, you get what?
Negative 8.
Negative
Doesn't
8.
Doesn't that mean the fx is odd function?
Okay, you can try put negative 1, right? You try to put f1, let's say that, right? 1 first.
Negative 1.
5 minus 5, 1 square minus 3, which is, what you get? Minus 8, right? Then you put minus 1. Minus 5 minus 1 square minus 3, what do you get?
Minus 8.
Minus 8 as well. You get minus 8 as well, same. This means that even though positive or negative does not matter because it will end up with the same answer. For the case like that, a function is an even function. You try with another number. Let's say you put 2. If you put 2 here, minus 2. Not 2 and you change with minus 1. When you compare 2 with minus 1, definitely different. 2 and minus 2. So it's going to be 2 minus 2. At the end, you're going to get minus 23, right? It's going to be same here, minus 23 as well. If you put 3 and minus 3, also same number here. Meaning that regardless either x or minus x, the value is still same. So how do we know that? We test it. But that's why this one is important. Early of the class, I said that. We test. This is the case for the even. For odd. For odd what? For odd. This is the case for the even. For odd,
f negative x equal to
minus x equal to
negative f
minus
x.
fx. For that case, this is odd, right? We change another function. Change another function, x to the power of minus 5. X to the power of minus 5. Even function or odd function? Even function or odd function?
Odd function.
Odd function. How do we know it's odd? We test. We put in the place. This is equal to 1 over to the power of 5. Another way to write. Remember the index. I think index is very common. You learn already when you were in school in SPM. X power of minus 5 same as 1 over x power of 5. Hopefully that you know this. If you do not know this, you're supposed to know this. That's why to enter institution, whatever institutions, they have entry requirements to make sure that those who enter definitely know this. Because you pass the entry requirements. Now, if given the x power of minus 5 equal to 1 over x, not many that you blur, right? No. You know, oh yes, I know. This. Okay, now we substitute f minus x is 1 over, in the place of x, change into minus x to the power of 5. Which is equal to 1 over minus x to the power of 5. If you look at the previous example, x power of 2, so it's going to be same. But power of odd number is going to be different. This is equal to minus 1 over x to the power of 5. Same, these two same. These two same. And then this is like that minus of, what is this? This is fx. This is fx. Meaning that f minus x is equal to minus of fx. Meaning that what? What the conclusions we can say, we can make that our function is odd function. Odd function. Right. So different from the previous one, because the previous one, when we substitute x with minus x, we get same as this. But for this, no, not same. It is same as minus of. Why? Because x power of minus 5 is changed into 1 over x power of 5. We change. Let's say another function. Function fx equal to x over x square minus 1. X over x square minus 1. We do the same thing. F minus x minus x divided by minus x square minus 1. So we have minus x over minus x square is what?
X squared.
X square. X square minus 1. This is same as minus x over x square minus 1. Same. Minus x over x square minus 1. And what is this? X over x square minus 1. Fx. Which means that f minus x equal to minus of fx. Which means that what conclusions we can say? Fx is an odd function. Odd. Right. We always test by substituting x with minus x. Look what happened. Right. Then we have another function. X cube minus x power of 7 plus 1 over x. Test. Determine whether the function, even function, odd functions, neither even nor odd. So what we do, same. F minus x power of 3 minus x power of 7 plus 1 over minus x. Minus x to the power of 3. Minus x to the power of 3. What do you have?
Negative x.
Negative x power of 3.
Minus x to the power of 3 remain. Minus minus plus x to the power of 7. Then minus
1 over
1 over x. Look like this. When you substitute x with minus x, it is same as minus x to the power of 3 minus x to the power of 7 plus 1 over x. If you expand, it's going to be this. Minus x to the power of 3 plus x to the power of 7 minus 1 over x. And this one, same as this. Which means that our f minus x is equal to minus of fx. And what can we say? This function fx is an again odd function. Right. Again, odd function. Why odd function? Because this. Because of this. Now, again, we change. The function with cube root of 3x power of 3 minus 2x. And we add some more in the questions. State the domain of the function. After we determine, we have to box, in fact, this question. After we determine that function, either even function or odd function, or maybe neither odd nor even, and then we need to determine what is the domain of this function. First step to determine whether even or neither. what we do? F minus x is cube root of 3 minus x cube minus 2 minus x. Nah. Right. We just substitute x with minus x. Then it's equal to cube root of what?
-3
Minus
x square
x power of 3
plus 2x.
Plus 2x.
plus 2x. So it's the same as fx. It's the same as fx. It's the same as fx. It's the same. Is the same or not as fx?
No, sir.
No,
Either even or odd function.
not same. So we cannot say that. We cannot say that is even function. So if it's not even function, we have to test whether it's odd function, because not necessarily that when not even function is going to be odd. Not necessary. Can be neither. Now we want to test for odd. Odd is this. F minus x is minus of fx. So we have to change in terms of minus on this. And we have to show. If cannot show, yes, it is neither. This is same as minus 3x power of 3 minus 2x. After expansions, we get 3 minus 3x power of 3 plus 2x. You understand it? Same. These two same. Then
The function is an odd function.
it's the same as this. We don't prove yet, right? It's negative of fx. It's negative of fx.
No.
Not yet. Cube root of, here we change into minus 1 times 3x power of 3 minus 2x. This is minus 1. Similar when we study this, minus 6 is minus 1 times 6, right? Remember when we study complex number, all right? This is square root of minus 1, square root of 6. This is I6 or 6I. That's when we talk about complex number. But now, not square root, this cube root. We change this in terms of minus 1 times minus 3x cubed minus 2x. You get it? We just change. Because this is minus 1. As I said before, that in mathematics, we have many numbers that we do not see. We cannot see. In fact, in front here is minus 1. Minus 1 here. Like number of minus 2. In fact, it is minus 1 times 2. So, minus. What you have here? Minus 3x power of 3 plus here is that we have minus 1 here. Minus 1 in here times this. Minus 1 times with 2. Minus 1 times with this. You understand? I always say to students before that, we only look complicated because we try to think of simple number, minus 2. It is minus 1 times 2. See like this. Only when goes to x over 3, we cannot see. Why I say that? Remember computing the square. When put number, for example, 2x cubed plus 3x minus 5, then I say that I do complete the square, right? Remember that for quadratic composition, they can solve. They can get the value of x. But when I put there px plus q plus d, find the value of x. Cannot. Why? Because they look complicated. In fact, no. It's like this. You look like this. So, this is same as cube root of minus 1 multiplied by cube root of 3x squared minus 2x. Same as this. This is same as cube root of minus 1 times cube root of minus 2. Cube root of 2, sorry, cube root of 2. Same. Easy, can you see? Look carefully. Same, only now we play with a big number with x, but now we go to the small number. Same. Same. We separate into two parts. One part is minus 1. One part is 3x cubed minus 2x. Same like this. We separate into two parts. One part is minus 1. One part is 2. In fact, it is same. Now, cube root of minus 1. Cube root of minus 1 is minus 1. Multiply by cube root of 3x squared minus 2x. Cube root of minus 1 is minus 1. Cube root of 3x squared minus 2x. We do not, just go straight this. Therefore, what is this one? What is cube root of 3x squared minus 2x? What is this one?
fx.
We can say that f minus x similar is minus of fx. Can you see? Therefore, our function, this function, is an odd function. Because fulfill these requirements. The second requirement. Why? Because we try to substitute with minus x. So what we get? This. This is minus of fx. This is fx. Okay. So if you're confused, try to imagine with small number. Always try to imagine with a small number. Right. So second part is to find the domain of this function. Right. Before we find the domain, we break for and come back at 11 o'clock. And try to understand this. Break and come back at 11 o'clock. Right. Right. You ready to come back? You ready to come back?
Yes.
Okay. Right. And now we want to find the domain. So when we look at our function here, cube root, it's involved of the cube root. So when it's involved of the cube root, as I said, that inside the cube root can be number negative. Only for the square root cannot be number negative. Inside the cube root can be number negative. Therefore, what is the domain? domain of this function? What is the domain? Cube root can be number negative. Can be number negative. Can be number negative. So what is domain?
Minus infinity to and minus 1.
Minus infinity to minus 1. If you say to minus 1, what happened to 0? When you put 0? When you put 0? If minus infinity to minus 1 only, which means that you cannot include number 0 and above. So what happens if you include 0? You try to go back to our function. What happens if you put 0? What happens if you put 0?
The answer is 0, sir.
The answer is 0.
0.
So, is that can?
Yes.
Can. So that you can include as well. You can include 0. So if you put 1, what happens if you put 1?
One, sir.
1. Is that defined? Defined. Therefore,
Yes.
it cannot just stop at 1. It cannot just stop at minus 1. You understand?
Yes.
You understand the meaning of the domain? Domain is some sort that you put, make the function define. You say from minus infinity to minus 1, let's say you say to me, from minus 1 to minus 1. So you test with whatever the number outside is. You test. When you test, you put 0, define. So cannot be the domain up until minus 1. So go to until where?
Zero.
Infinity.
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 Because all the number can be put. All the number can be put there. You can substitute whatever the number. Why we do not have restrictions? Yeah, because cube root. Cube root. Because of the cube root. So domain is from minus infinity to infinity. Right. Let's say we have another function. Let's say another function. Fx equal to x to the power of 5 plus cube root of x, and then state the domain. So what is this function?
Odd function.
Odd, sir.
Okay. We test. F minus x to the power of 5 cube root of minus x. So we get minus x to the power of 5 plus cube root of minus x. Minus x to the power of 5 minus x to the power of 5 plus cube root of minus 1 cube root of x. We change cube root of minus x as cube of minus 1 cube root of x minus x to the power of 5 plus, this is minus 1 cube root of x, or minus x to the power of 5 minus cube root of x. This is minus x to the power of 5 plus cube root of x, which is fx. Therefore, this function, again, odd function. And what is the domain? What is the domain?
Negative infinity to infinity.
Domain, again, because it involves of the cube root, negative infinity to infinity. Right. Let's say another function square root of x plus 1 over x squared minus 4. And then state the domain state the domain even or odd function.
Odd.
Odd function, which means that when we substitute with minus x, we get minus fx. I will try to substitute. Square root minus x plus 1 minus x squared plus 1. Square root of minus x plus 1 over x, minus 4. Minus 4. Definitely not same like this fx. Definitely this is not minus of fx. This is not minus of fx. Minus of fx is minus this. This is minus of fx. This minus of fx, but it's not different. It's not like this. And therefore, this is the case of neither even nor odd. Fx is neither even nor odd function. Neither even nor odd function. Right. You get it? Why I say that neither even nor odd. Because when we test, yes, we cannot have both of them. We cannot have that when we substitute x with minus x, we cannot have is equal to fx. Definitely it is not an even. And then we cannot have minus of fx. Also, we cannot say this is odd function. Therefore, neither even nor odd function. Right. Now, please on your camera, right? Then next stage is to find the domain of the function. So domain of the function, remember that inside a square root here, everything here must be positive. To find the domain. To find the domain of the function, everything here must be positive. And definitely, minus x plus 1 must be greater than 0. Or at least equal to 0. Right? If we have something which is less than 0, it's going to be negative. It's going to be negative. Right. And also we have our denominator, x squared minus 4 must be greater than 0. Positive and also cannot be 0. Right. Understand these two statements. Now we're in the process of finding the domain. X plus 1 must be greater than or equal to 0. 0 can be because numerator. But for x squared minus 4 must always greater than 0, cannot be equal. Because it is denominator. Denominator cannot be 0. Right. So we have here x must be greater than or equal to 1. Right. Any questions so far? And here we factorize factorize. We factorize, we get x plus 2, x minus 2 greater than 0. Now it's involved of the inequality. Even here involved of inequality, but it is linear. But now it's quadratic. When involved a quadratic inequality, what we have to do next?
Find the critical number.
Critical number. So critical number is x equal to 2 and x equal to minus 2. Two numbers, critical numbers. Minus 2. From here is minus 2. From here, 2. Sign diagram. Minus 2, 2. X plus 2. X minus 2. Resulting sign. Negative. Negative. Positive. Right. Any question? Right? Look about the inequality. We still in the process of finding domain. We did not find a domain yet. We in the process of getting domain. We not find a domain yet. Next. Next.
Positive, negative,
Positive.
positive,
Positive.
negative,
Negative.
negative,
Negative.
positive,
Positive.
positive, positive.
Positive.
So, this one. Right. So, in between minus 2, minus infinity, minus 2, union with 2, infinity. Right. You get it. You get it? That's from right. From left. From here. From here, what? In interval notation, from here. From
1 to infinity.
1 including infinity. Right. Remember that left and right connected by n. That's important. And meaning that we have to find the intersection. Now we go to the number line. It's like this. Minus 2, minus 1, 2. Right. Those three numbers. From left, minus 1, 1. Sorry, 1, 1. Not minus 1, 1. Right. From left, 1. From left. From left.
1,
1.
infinity.
So we write like this. 1 including. This is including. Remember that. Whole, bold. Until infinity. Right. That from left. From right. From right.
Right.
Negative 2 to infinity.
To neg
Negative 2 including or not including?
no.
Not including.
Not including. Until
Negative infinity.
Negative infinity.
another one.
2 to
to
positive.
to infinity. Like this, right? You understand? Eh? This one, our left. These two, our right. Because they are connected by the word and. So what happened here? What happened? What will it be here?
Intersection to until infinity.
Interception. So interception where? Where the place of interception? Only this. The place of interception. So we can say what? What we can say about the domain? Domain of fx is
2 to positive infinity.
2 to positive. 2 including or not?
Not including.
Not including. Positive infinity always not including. And this is the domain. Because connections between left and right and because we have two parts, one for numerator and another one for denominator. Right. So two parts of these questions. The first part is to determine whether the function even odd. The second part is to determine or to find the domain of the function. Like what we did last week, how to find the domain of the function. So, domain of the function we get is from to infinity. We want to make sure whether it is correct or not. Try to take one number outside this. What the number outside this? Give me one example of the number outside of this. What? One example of the number of outside of this. What?
How about
One.
one? Sir?
One. Let's say outside this one something. Try to put. Can be or not. Try to substitute. Can. Can.
Cannot say.
Cannot. So another one to make sure. Take one number inside this. Try to substitute there. Can or cannot. What a number inside this?
3.
3, for example. Try to substitute. Try to substitute.
Can say.
Can. Therefore, it's correct. So, simple. It's simple. Then the meaning of this. What is the domain? Domain is number you can substitute to make function defined. If that number we choose make function our function undefined, no, not in our domain. You substitute a number outside the region, cannot. Only the number inside this can be put there. Now, whether 3, 4, 5, 6, etc. Right. And let's say another function. Fx is absolute value of x plus 5 divided by 3x squared minus 2. First, test whether this function is even or odd function. Then state what is the domain of this function. Even or odd?
Even.
Even. How do you know it's even? Why it's even?
Because the x can be negative and positive.
Because when you substitute x with even for negative number, you're going to get same value. So that's not matter. Therefore, this function is even function. Okay, the first. Then, what is the domain of this function? What is the domain of this function? From the definition, the domain is some sort that numbers you can substitute into the function, into the variables, make our function defined.
Negative infinity to infinity.
Negative infinity to infinity. Okay, what happens if we substitute with square root of 2 over 3? Square root of 2 over 3. Can we substitute with square root of 2 over 3? Can or cannot? Meaning that we substitute x with square root of 2 over 3. We substitute x here with square root of 2 over 3. What happened? What happened? If you say the domain is from minus infinity to infinity, which means that every number, but you try to substitute with square root of 2 over 3. Then you see what happened to our function.
Math error, sir.
Why math error?
Because divide by 0.
Because divide by 0. Therefore, what the conclusion you can say? What is the domain you can say? What is the domain?
x is not 2 over 3.
Okay. What happened if you substitute with minus square root of 2 over 3? Now, minus square root of 2 over 3.
Cannot say.
Now, two numbers that we got. In between minus infinity to infinity, as you said that, two numbers already we cannot include. So that these two numbers must be excluded. So what can we say? What can we say? What can we write a domain?
Negative infinity.
Domain of fx minus infinity
Negative
minus
square root 2
square
over 3.
root 2 over 3.
And then square root 2 over 3.
Union, right?
Yeah, union.
Union square root of
2 over 3.
negative square root of 2 over 3
Or 2 square root 2 over 3.
and t square root 2 over 3. Because can. Number in between these can. Only these two number cannot. Union with square root of 2 over 3 until infinity. Another meaning of this, meaning that all the numbers you can include except that negative square root of 2 over 3 and square root of 2 over 3. That's another meaning. So cannot, it's not that from minus infinity to infinity, no. Because we do have, because remember that when we have fraction, you have to be careful. Always I say that. When we have fraction, you have to be careful. Because instead of we can take all the numbers from minus infinity to infinity, we may have number which cannot be put there. Yes, when we test, yes, two numbers cannot be put there. Minus square root of 2 over 3 and plus square root of 2 over 3. The rest can. Because it's nothing to do with this. This doesn't matter because it's absolute value. Even though negative number can become positive, or even negative number can be even number 0 appear. That can be because it is numerator. Numerator does not matter. Denominator have to be matter. Denominator cannot be 0. Clear? If unclear, if understand, ask. Asking, it's nothing to do. Nothing less, nothing, not make that you look like, no. Ask.
Sir,
Yes?
how did we want to know that we have to put square root 2 over 3 into x?
Because number here. Number 2 and 3 and 2. From this number we can see what number which make that 0. If let's say here 5, 2, so square root 2 over 5.
Right, sir.
Okay. So unclear, you ask, right? Every unclear you ask. Every unclear you ask. Who is your academic advisor? You from engineering course, correct? Who is your academic advisor? Right. It does not mean that I want you to do the. Your academic advisor is a very important person for you. Apart from your lecturers who teach, right? Because they know that your route, your path with this semester, what is the requirement. They're supposed to know. He or she, I don't know. Because I'm not academic advisor for engineering. And they are not just there. They're getting paid for that. Not because of that I say that I want you to do. No, because same people who have a problem, who have something, who is supposed to speak more. In this place, we have counselor, right? And they're getting paid for that. But nobody look go to that. No, not go because now we're in the COVID. No, not go. Nobody ask her, oh, if you don't know, you try to know. And then you may ask them. If you have a problem, if you don't have a problem, doesn't matter. I always say to the previous students, right? Does not say to them that I would like you to ask them. No, not because of that. Because they know, your advisor know much more know that. I know that about this, right? But what is your requirement for this? What requirement for that? They must know. Right. So try to during the lessons, if you have a problem, you ask. So they know that what you're supposed to get to enter the faculty of engineering for each subject. If I'm not mistaken, B. If I'm not mistaken, I don't know because I'm not a right person to tell you. We have a right person to tell about this. They know everything. So tonight, you look back at this, right? Try to remember that our topic today is only two. If you look carefully, only two today, right? Even to look very long, right? One, to determine even-odd function. Second, to determine the domain of the function. Even the domain of the function we already did last week, right? So look back at this. So I stop here, and inshallah, remember that tomorrow we don't have a lesson. According to the timetable, yes, we at 11 o'clock, but tomorrow is a public holiday. So we don't have a lessons. So inshallah, we'll meet you again on Thursday morning, 8 o'clock. Okay, with that, I close the sessions today with Tasbih Kifarah and Surah Al-Asr.
Thank you, sir.
Yeah.
Thank you, sir.
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 Thank you, sir.